Welcome to the deep dive. Okay, so you're building with Ruby on Rails, things are humming along, but then you start hitting those more complex background tasks,
hmm
maybe like long data imports or, those multi-stage user signups, and suddenly background processing feels a bit, well, shaky.
Yeah, keeping everything in sync, making sure it all actually finishes without errors, that can turn into a real headache, can it?
Exactly. So today we're diving into a really interesting potential fix for this. Moving background jobs from, the standard Sidekiq over to something called temporal.
Right.
We're using the article Migrating Sidekiq Background Jobs to Temporal in Ruby on Rails as our guide. And our mission really is to just cut through the jargon, understand the core differences, the benefits, the drawbacks.
And figure out when making this kind of switch is actually worth it, when it could be a real game changer for your app's reliability.
Yeah, and we'll look at some code examples too, just to make it a bit more concrete.
Definitely. Because this isn't just, swapping one gem for another. It's a pretty fundamental shift in how you handle background work.
A rethink.
Yeah, especially for those critical, long-running, or maybe multi-step things. We want to get past just the feature lists and really talk about the why. Why choose one over the other? When does temporal give you that big leap in robustness?
Okay. Now, most Rails folks, we've all used Sidekiq. It's been the go-to for ages. But maybe for someone newer or who hasn't dug in deep, what is Sidekiq fundamentally?
Sure. So Sidekiq is basically a super efficient background job processor, right? Made for Ruby, specifically Rails. Think of it as the engine running all those tasks you don't want users waiting for.
Like sending emails, processing payments?
Exactly. Updating search indexes, that kind of stuff. Uses Redis underneath, which is why it's so fast. It's really good at handling like tons of short, separate jobs running at the same time.
Okay.
Think of it like a busy dispatch center, just firing off packages really quickly. That's Sidekiq's sweet spot.
Right, high speed, lots of individual packages. Got it. Now, temporal, the name kind of sounds different, more permanent. What's the core idea there?
Temporal is, it's different. It's an open source workflow orchestration engine. The big word there is orchestration.
Okay.
It's not just about running a job. It's about managing whole sequences of tasks, workflows, which might take a long time, involve many steps. And temporal actively manages the state of these workflows.
Indeed.
Yeah, where it's at in the process. And crucially, it guarantees they'll finish eventually, even if things crash, like
Yeah.
servers, workers, whatever.
Okay.
So if Sidekiq is the dispatch center, temporal is more like a symphony conductor, making sure every part plays correctly in order, even if there are interruptions along the way.
That conductor analogy really helps. Okay, let's dig into the nuts and bolts then. The article flags some key distinctions. First one, state and durability. What's the real world difference there?
Okay, so think about risk. With Sidekiq, a job usually just runs. If the worker crashes halfway through, poof, any state it held in memory is gone. Right?
Sidekiq has retries, sure, but it doesn't magically know how to pick up exactly where it left off inside the job logic. You'd have to build that yourself, maybe saving progress somewhere. Temper flips this. Workflows are durable. Their state, how far they've gotten, the data involved. It's constantly saved by the temporal system.
Ah, okay.
So if a worker dies, temporal just finds another worker and resumes the workflow right from where it paused, like an auto-saving document for your background tasks.
Okay, that's a big deal.
Huge, especially for long-running things or critical stuff where losing progress is, bad news.
That makes the resilience part super clear, doesn't it?
Yeah.
Okay, next difference. Retries and fault tolerance. Sidekiq does retries, so how is temporal different or better here?
Yeah, Sidekiq's retries are good for, like, temporary glitches. You can set how many times it tries again if a job fails.
Right.
But temporal handles retries a bit more granularly, especially at the activity level within a workflow. Think of an activity as just one step in that bigger symphony.
Temporal can automatically retry just that specific activity if it fails. Maybe with backoff, waiting longer each time until it works or hits the limit you set.
Interesting.
Super useful for things like calling flaky external APIs or temporary network blips. It makes sure each individual step gets done reliably without you writing tons of custom retry code in your job. It's like built-in quality control for each stage.
So it's not just retrying the whole thing, but the individual problem step.
Got it. Now, this workflow versus job model seems like a pretty fundamental split.
It really is. Sidekiq is all about individual jobs. You define job A, job B, job C. Sure, you can make job A trigger job B, but you have to manage that chain. What happens if B fails? How do you roll back A? That's on you.
Right, you end up building state machines yourself sometimes.
Exactly. Temporal gives you a proper workflow programming model. You define the whole sequence, the steps, activities, and temporal handles the order, the state, making sure the whole thing completes.
So less manual wiring needed. Way less. Instead of chaining jobs and hoping for the best, you get a structured, reliable way to define and run these multi-step processes with guarantees built in. It's like managing errands versus having a full project plan that tracks everything.
Okay, that makes sense. Higher level organization. What about those jobs that just run
Yeah,
forever
sure.
or seem like it? The article mentions long running processes. How do they differ here?
This is a huge one. Sidekiq is optimized for speed, for jobs that finish pretty quickly. You can run long jobs, but they can tie up worker threads for ages, hurting overall throughput.
Mm-hmm.
And worse, if a worker crashes during a really long Sidekiq job, you might lose hours of work and have to start over.
Ouch.
Temporal. It's designed for long-running workflows. Hours, days, weeks. Doesn't matter. Because it saves the state. There's no built-in time limit imposed by temporal itself.
Wow.
This really opens doors for stuff like complex financial reconciliations, massive data migrations, or even processes that need human input and might pause for days. It's a totally different ballgame for those marathon tasks.
That is a game changer for certain use cases. Okay, shifting gears. Scalability and concurrency. Both need to handle load. How do they approach scaling up?
So Sidekiq scales mostly by adding more threads within each worker process and then running more worker processes, maybe on more machines. It's great at blasting through many quick separate jobs in parallel that way.
Okay.
Temporal scales by distributing the work across a whole cluster of temporal server nodes, and you run lots of workers, potentially anywhere. Plus, a single temporal workflow can easily trigger many parallel activities or even child workflows. The temporal server is smart about farming this work out.
So Sidekiq is more about concurrency inside workers. Temporal is more about distributing complex workflows across the system.
Yeah, that's a good way to put it. Sidekiq excels at concurrent short tasks within its model. Temporal is architected to scale out these potentially long, complex workflows across a distributed setup with smart load balancing.
Right. Now, debugging. Nobody's favorite topic. How do visibility and debugging stack up?
Both have web UIs, which is helpful. Sidekiq's UI mostly shows you job status.
Mm.
Queued, running, failed, retried. Useful, but kind of high level.
Mm-hmm.
Temporal's web UI gives you way more detail. For every single workflow run, you get a complete, unchangeable history. Every event,
Yeah.
which activity ran, what it returned, did it retry, any state changes, everything.
A whole audit trail.
Exactly.
Yeah.
It's incredibly valuable for debugging tricky workflows, especially figuring out why something failed in a long, multi-step process. It's like having a flight recorder for your background tasks.
That sounds like a lifesaver for those really nasty, hard to reproduce bugs. Okay, briefly. Language support. Sidekiq is Ruby, right? What about temporal?
Yep, Sidekiq is pure Ruby, deep in the Rails world. Temporal, though, is built to be polyglot. The server doesn't care about the language.
Oh.
Yeah, there are official SDKs for Go, Java, Python, TypeScript, .NET, lots of stuff.
Hmm.
And for Ruby, there's the community temporal-ruby SDK the article uses, plus an official Ruby SDK that's being actively developed now.
So it plays well with others.
Definitely. Big plus if your company uses multiple languages or might in the future.
Okay, so let's try to summarize this comparison then. It feels like Sidekiq is your reliable choice for high throughput, quick, mostly independent background jobs.
Right, the sprinter.
And temporal is where you turn when you absolutely need guaranteed execution, durability, and solid orchestration for a complex, stateful, maybe really long-running stuff.
Exactly. Temporal is the marathon runner for those critical, intricate processes where failure or losing state just isn't acceptable.
Okay, so temporal sounds amazing, powerful, but the article also gets into the challenges of adopting temporal. It's not just a drop-in replacement, is it?
No, definitely not. Despite all the benefits, moving at temporal is a pretty big shift. One of the main hurdles is the new programming model.
Right.
You can't just point temporal at your old Sidekiq jobs. You have to break them down, rethink them as workflows, the orchestrators, and activities, the actual work units.
Okay.
And, this is super important, the code inside your workflow itself has to be deterministic.
Deterministic meaning.
Meaning it has to produce the same output, given the same input, every single time. No random numbers directly in the workflow, no relying on time.now without using temporal special APIs for that.
Why is that?
Because temporal might replay parts of your workflow history to ensure consistency if there's a failure. If your code wasn't deterministic, the replay could lead to different wrong results. It forces a different way of thinking about that orchestration logic.
Huh. Okay, that sounds like a potentially tricky mindset shift. What's another big challenge?
Infrastructure. The infrastructure overhead. Sidekiq is pretty lean. You need Redis and your workers.
Yeah.
That's mostly it.
Yeah.
Temporal is a distributed system built for high reliability, so it needs more pieces. The temporal server cluster itself, plus a database backend to store all that workflow state.
There's more stuff to manage.
Right. You can self-host it, which adds operational complexity, or use something like Temporal Cloud, which manages it for you, but that has its own costs and things to learn. It's definitely a bigger infrastructure footprint than just Redis.
Okay, more moving parts operationally. What about the learning curve for the dev team?
The learning curve is real. Developers need to get their heads around new temporal concepts. Things like signals, queries, timers. These are core to how you interact with and manage workflows.
You mean those queries?
Yeah, ways to send information into a running workflow or ask it for its current state. It's a different way of thinking than just firing off a Sidekiq job. It takes time for a team to get comfortable with this new model.
And does it change the day-to-day coding workflow too? The article mentioned that.
It does. Development workflow changes. You'll almost certainly need to run a local temporal server, probably using Docker, while you're coding and testing.
Okay.
And testing itself might lean more towards integration testing, spinning up the server, workers, and seeing how your workflows and activities actually interact, rather than just unit testing a single job in isolation. This can make the feedback loop a bit longer sometimes, compared to pure Sidekiq job testing.
Right. And then once it's live, in production, are there new things to watch out for operationally?
Oh yeah, operational considerations are different. With Sidekiq, you mainly watch Redis and your workers. With Temporal, you're monitoring the temporal cluster health, the database performance, maybe things like workflow history size, because that history grows.
History size.
Yeah, if workflows run for a very long time or have tons of events, the history can get large, which has performance implications.
Yeah.
You also need to think about namespace management, task queue health, maybe rate limits. It's just a more complex system to operate.
It definitely sounds like a trade-off. You get a lot more power and reliability, but you also take on the more complexity DevOps infrastructure.
Exactly. But as the article points out, for that complexity, you get reliability at scale, built-in retries, and a powerful stateful model.
Right.
For teams hitting the limits of basic job queues with really critical or complex stuff, that trade-off, that investment in learning temporal, can be totally worth it for the reliability gains.
Okay, so let's say someone's listening and thinking, okay, I'm intrigued. How do I actually start playing with this in Rails? The article walks through the basics with the temporal-ruby SDK.
Right. First step is setup. You need a temporal server running somewhere. Locally, Docker is usually the easiest way, like the article suggests.
Mm-hmm.
For real deployments, you either run your own cluster or use Temporal Cloud. Then in your Rails app, you add the temporal-ruby gem to your gem file. Run, bundle, install. Standard stuff.
And then you need to tell Rails how to talk to temporal
Right.
configuration.
Exactly. The article shows a simple initializer, maybe config initializer, temporal.rb. In there, you set things like the temporal server's address, host and port, the namespace you want to use.
Namespace.
Yeah, it's like a logical separation within temporal, good for separating dev staging pride or different apps. You also set a default task queue name.
Task queue. That's how workers find jobs.
Precisely. Workers listen on specific task queues. The initializer example also shows how to check if the namespace exists and create it if needed.
Okay, gem installed, connection configured. Now you need the actual code, the workflows and activities.
Right. Defining workflows and activities. With temporal-ruby, an activity is just a Ruby class that inherits from temporal.activity. That's where your actual business logic goes. Download the file, send the notification, whatever.
And the workflow.
That's a class inheriting from temporal.workflow. It orchestrates the activities. Inside the workflow code, you call something like your activity class.execute to run an activity. The article has basic hello activity and hello world workflow examples.
So activities do the work, workflows direct the traffic. Once those are defined, how do you run them? You need a worker.
Correct. You need separate worker processes. These listen to a task queue and run the workflows and activities they know about. The article shows setting up a temporal worker, registering your workflow and activity classes with it, and then just calling worker.start.
And that worker just sits there polling temporal.
Yeah, constantly asking the temporal server, got any work for me on this task queue?
And the final piece, how do you kick off a workflow from your Rails code?
He used temporal.start workflow. You give it the workflow class you want to run, any starting arguments it needs, and importantly, options like the task queue and a unique workflow.
Why is the ID important?
Idempotency. If you try to start the same workflow with the same ID twice, Temporal recognizes it and just gives you back the first one. It doesn't run it again. Prevents accidental duplicates.
Ah, very useful. Okay, that covers the building blocks. Now, the article has that great example, replacing a long-running Sidekiq job. Let's unpack that.
Yeah, it's a good one. Takes a typical multi-step Sidekiq job, process file job, download, parse, store, notify. Classic background task. It shows how you'd break that single job down into separate temporal activities. Download file activity, parse file activity, store results activity, notify user activity. Each does just one thing.
Okay, decomposition.
Exactly. Then it shows the process file workflow orchestrating them, calling execute on each one in sequence.
It really highlights that shift from one big job to a managed sequence of smaller steps. And didn't the article mention something important about passing data between activities?
Yes, crucial point. It mentions a potential 2mal-B size limit on data passed between activities in temporal-ruby, and also some potential gotchas with deeply nested JSON.
So you can't just pass huge objects around.
Probably shouldn't. The advice is to keep the data returned from activities small, maybe just true or nil, to signal success. If you need to pass large amounts of data, better to have one activity, save it somewhere external, like S3 or Redis, and the next activity fetches it from there.
Okay, avoids hitting internal limits. Good practical tip. Then the article shifts to a really complex case, managing complex deployment workflows at the company release.
And this sounds like exactly where Temporal would shine.
Totally. Deployments can be super complex, right? Multiple stages, parallel tasks, dependencies. Release built their own system on Sidekiq using something called Sidekiq Job Group to try and manage this.
Like wait for a group of jobs to finish.
Yeah, but they ran into issues with the group. Join method blocking Sidekiq worker threads while waiting. This caused bottlenecks and scaling problems, especially with really complex deployments. Ah, the classic blocking problem. So how did Temporal help them?
Well, Temporal's whole thing is orchestration, so it's a natural fit. They modeled their deployment as a main deploy workflow, which could then start and manage multiple child deploy task workflow instances for specific parts.
And now the waiting part.
That's the key. When a temporal workflow waits for a child or an activity, it doesn't block the worker thread. It just yields. The temporal server keeps track and tells it when to wake up again. This completely avoids that thread contention issue they had. Much more scalable.
So Temporal handles the waiting in state without hogging resources. The article lists specific reasons why Temporal helps here. Can you recap those?
Sure. 1. Automatic retries per activity makes individual deployment steps more robust. 2. Resuming after crash. If a worker dies mid-deploy, it picks right back up. Crucial. 3. Visibility. That detailed web UI history makes debugging deployment failures way easier. And 4. Stateful orchestration. The workflow itself tracks the deployment state automatically.
It really drives home how Temporal's built-in features tackle the exact problems you face with complex, stateful sequences that are hard to build reliably on top of a basic job queue.
Absolutely. When you go beyond simple background tasks, Temporal's design starts to pay huge dividends.
Okay, what about raw speed? Performance considerations. Sidekiq is known for being fast. How does Temporal stack up?
Yeah, Sidekiq can push through a lot of small, quick jobs very, very fast. Minimal overhead. Temporal, because it's constantly tracking state and history for durability, has inherently more overhead per operation.
So for sheer speed on tiny tasks, Sidekiq might still win.
Potentially, yes, if raw throughput of very short jobs is your absolute #1 priority. But Temporal's strength is in reliability for complex or long-running tasks. It handles those gracefully, where Sidekiq might struggle or require complex user code.
So performance isn't just about speed, but also about successful completion.
Exactly. And Temporal's exactly one's execution guarantee via the workflow is also a kind of performance benefit, prevents costly duplicate processing.
Right. And the article suggests maybe you don't have to choose a hybrid approach.
Definitely. That's often a really smart strategy. Use Sidekiq for the high-volume, quick, less critical stuff. Use Temporal for the complex, long-running, mission-critical workflows where you need those guarantees. Best of both worlds.
Okay. Lastly, tooling, development cycle, and observability. Quick rundown of the differences there.
Sure. Local development Temporal needs that local server running, often via Docker, which is an extra step compared to just Sidekiq Redis. Tooling Temporal has TSTL, a command line tool for interacting with workflows, which is pretty powerful.
Okay.
The Web UI Temporals gives that super detailed event history, much richer than Sidekiq's for debugging flows. Metrics and tracing. Temporal emits system metrics. Getting deep insight into complex Sidekiq flows often requires more custom setup.
And code updates. Versioning.
Yeah, that's important with Temporal because workflows can live a long time. You have to think about workflow determinism and how code changes affect running workflows. Versioning strategies become more critical than with short-lived Sidekiq jobs.
So maybe a bit more setup for temporal dev, but potentially better built-in tools for managing complexity later on.
That's a fair summary. Temporal gives you more out of the box for observing and managing those complex, stateful processes once they're running.
Well, this has been incredibly illuminating, a really thorough deep dive into temporal versus Sidekiq for Rails background jobs. It's definitely clear that temporal offers a pretty significant shift towards thinking in terms of stateful, durable workflows. It brings enhanced reliability, much better visibility, especially for those really complex or long-running tasks where Sidekiq alone can sometimes feel a bit fragile.
Absolutely. And while, yeah, adopting temporal means learning new concepts, dealing with more infrastructure, its core strengths, the guaranteed execution, the handling of long processes, that detailed audit trail, make it incredibly compelling when your background needs get serious.
Right.
And like we said, that hybrid approach, using both tools for what they do best, that's probably the sweet spot for a lot of applications.
So for everyone listening, maybe think about your own background jobs. Where are the pain points? Where could the guarantees, the orchestration, the visibility of something like temporal make the biggest difference? What's one part of your system where that built-in fault tolerance could really give you peace of mind?
Yeah, good questions to ponder.
Definitely check out the resources mentioned in the article, the temporal docs, the Ruby SDK info, Sidekiq docs to keep exploring. Thanks so much for joining us on this deep dive.